Hi guys, I'm Adam. I'm an architect. I'm working at Capgemini, and I'm running a group of enthusiasts of both Java and GenAI. So we create something called AI agents, right? So what is AI agent? So probably there are multiple definitions online. My definition is super simple. It's a piece of software which is using large language model to think and some external tools to action, and that's it, right? So if we take the super simple definition, then we can say we create those. Today I want to show you how they work. Let me start with a question that seems completely unrelated, right? So what was the last time you have renovated your house or apartment? Why I ask it is because when it happens to me, there is always some original estimation, let's say 4 weeks, and I end up in 12, right? Always. And there's the same happens to cost, always. And technical people that come to my place to renovate it, they say very bad things about the technical people that did the previous renovation 10 years ago. And I'm pretty sure 10 years from now, with the next renovation, they will say very bad things about those technical people that they have never seen, right? So it's similar to the problem of legacy software. So legacy by itself is not a problem, it's attributes of legacy that are problematic, right? So it's difficult to read. The code, of course, I'm talking about legacy Java code, let's say millions of lines of code in some retail investment bank, things like that. So it's very difficult to read. And people can say, so what, right? We don't really care that much. But a lot of studies show that developers spend 10 times more on reading than on writing. And in legacy, this proportion will be bigger, right? Because we even read more and write less. So probably we should redo our definition of a developer. Is no longer somebody who writes code. It's somebody who reads a lot of code and maybe sometimes writes a little bit, right? Legacy stuff has usually very low test coverage. At the beginning, I would say, of every project, the coverage is too low. And then over time, and if we talk about, let's say, 10, 12 years old projects, the coverage goes down because at some point of time, some tests are failing. It is so easy to turn them off, ignore them, remove them, right? It's so easy. The managers are pushing on deadlines, and it's so difficult to fix them properly. We don't know why they fail and so on. So the coverage goes down. So even if at the beginning it wasn't high enough, after 12 years it will be lower, right? So that's the worst, right? So actually it's a kind of consequence of the other two. When I work on legacy stuff in some investment bank, for example, I have a problem. So I fix it, I have a code change, I commit it, push it, I put it into some test environment, right? My particular problem has been fixed. The build is green because let's say there is 3% of test coverage. So of course my change is in the remaining 97, of course, right? So I ship it to production finally, and it looks good. My problem was fixed, but after 5 days, I noticed that my change has introduced a problem somewhere else. I had no idea that those two things are connected. And of course, now I need to roll back my change, meaning I have the original problem. I have, let's say, 5 business days of data that I need to fix, right? So a lot of time goes into rolling back, reverse engineering, fixing something we have broken. And if we find out 2 weeks from now, it's even worse, right? And so on. So this is where the time goes. So my idea was to take the best thing from IT now, meaning GenAI, right? And the worst thing from IT, meaning legacy, and just fix it, right? So if we just brainstorm a little bit how we could do this, if we put 1 million of lines of code into ChatGPT, it wouldn't work, right? So number of reasons. Of course, there are like context windows. It's too much. We cannot put it. But let's say we would overcome it somehow. The first answer from ChatGPT or whatever GenAI wouldn't even compile. It has no chance to survive, right? So we need to approach it somehow differently. So usually if the problem is too big, we just need to split it. If we think about Java, every code base is already split into classes. So we can just use this division, and we can say, for example, for every class in a given source, just GenAI give me unit test. And you can say, but it can give you something that doesn't compile, right? Of course, but if it doesn't compile, I have a compilation error, right? So I get this compilation error, and I feed it back to GenAI and say, hey, you gave me something that doesn't compile. And it says, oh, it's an import missing. Okay, so GenAI fixes it and gives us a new version of a unit test. But now let's say some assertion fails, right? And I say, you gave me this, and the assertion fails. And then I get a newer version without this assertion failing, or with fixed assertions or whatever. But finally, if we think about whatever is problematic with the code coming from GenAI, there is some technical problem with it. So we have exact error what it is, and we can just fix it. Once we have tests, so phase one is creating tests. Of course, for some, let's say, more difficult parts, there will be no test, because even if the dialogue between our agent and GenAI is, let's say, 32 times long, still there may be not enough information, whatever, to create meaningful tests. But let's say we will have 50% of coverage, right? So it's so much better than this free that we started with, right? And now we can refactor, of course, only the parts that are covered by tests, right? So now we don't no longer have 3%, we have, let's say, 50. I make this up because it varies from project to project. And now I can refactor. And it's not like I just refactor anything. I run, actually, it's not myself, it's an agent, right? So agent does all that. People do not touch it. So agent is running sonar, check style, this stuff, and for example gets output like a method is too long, the cyclomatic complexity is too high, right? So we say, hey GenAI, here this method is too long, split it. And actually in this part GenAI is very good, and it gives us the same method with the same parameters, just split into, let's say, two methods, and it gives them meaningful names based on the content, right? So here we can get some decent code. It doesn't work always, but in majority of cases we can get this. I have an animation that was just done this morning, so it may be fun. In general, how it works for the code. So this is the Java code. For every code, we try to get the test. For some classes, we are not successful, but we try, right? And we also have some resubmission logic and so on. So because the output of GenAI is code, we can be extremely restrictive about this. So it's not only compilation that we run, but we also check how long it takes to execute, and we only accept the tests that execute, let's say, below 100 milliseconds, right? For tests, we can run together the quantity measure, meaning coverage, and the quality measure, meaning mutation testing. If we have both, it's very difficult to work around this, right? And of course, we run sonar, check style, and that's all happening automatically. So there is no human intervention, right? So it's all going into loops, into this. It's a server-side process that you give a million lines of code, come back in the morning, and you get what you get. You get actually a pull request. And usually now people come and say, yeah, it looks good on PowerPoint, but you cannot use it. For example, I work in financial services, and they say, you cannot send any code to the internet because it would be a security breach, so it's useless, right? But it's nowadays it's super easy and cheap, and doesn't require extra hardware just to run a private AI instance. So what we do, we run something like Olama with Google Gemma 2, it's tiny, it's good, it's giving us very quickly results. It's runs on my laptop. Okay, I have some GPU on my laptop, but it doesn't really require much hardware. So there is completely zero problems with data privacy because we don't send it. There is no problem with code, intellectual property, because just client runs it on his computer. So basically, we cut off the discussions before they start. So what are the benefits, right? So if you can imagine being a member of the team from the beginning of this presentation, working on the legacy software, they don't feel safe, right? Whenever they touch something, they know something will break and they will not find out immediately. They will be to blame and they will have more work, right? Because they will have original work plus fixing it, right? So this can give them some kind of psychological safety, because if we cover everything in tests, I'm not saying that they will cover 100%, but at least they will have a way to find out if they break something bigger immediately, so they don't commit and push the change. If they don't roll back this production, that takes weeks to fix, and they need to convert data and whatever, they have more time. If they have more time, they can, of course, upgrade the technological stack of this legacy. They can rewrite it, redesign it. They can even go to another project, right? We can, change the team from 7 people to 4. We will not go down to 0, but, and then send the other 3 guys to the greenfield projects that I'm pretty sure they are, just waiting for that, right? And there is one thing that was kind of a cherry on top of the torte here, because by design there should be just 2 pull requests. One pull request with tests and the other one with refactor code. But sometimes it happens that GenAI gives us test, which is okay. As you have seen, all those checkboxes, all of them are green, but it fails. So in this case, there are 2 options. Of course, GenAI may be hallucinating. That's possible, right? But there's another option, that it found a bug. And what is more interesting here, if we talk to a stupid GenAI, let's say 3.5 or something smaller, it's more likely that it will find the bug than a smart one, because very smart ones, they understand the code and they will not create a test case that fails. They will create a test case that exactly expects what the code should do. When the small ones, they are not so smart and they are more focusing on names and they trust the names. So if they trust the names, they can come up with a test that fails. So if you can imagine that if GenAI can give you a Java test that fails and finds you a bug in millions of lines of code that you have not written, right, that you don't know, it can have great value, but those do not happen always. It's a combination of the input project plus GenAI that can give you this. Okay, so what is next? We have more agents. So another one is called DocumentAI. So it creates functional specification from sources. So often our clients come to us and they say that they have, like, I don't know, millions of lines in Java 7 or 6, and they have no idea what it's doing. And we just run it and create some nicely looking markups that tell us what it's doing. And, the idea here is to drop the dependency on the source technology. So let's say if I have Java code is full of hash maps, linked lists, technical things, right? And if some business analyst, for example, who doesn't speak Java, would like to understand what it's doing, it will probably stop on hash map, right? While here, this would generate something, let's say, an example, this code takes all employees and returns only active employees. So it's defined in a business terms. It's a domain kind of language. It no longer speaks Java. It doesn't require you to understand hashmap or something, but it tells you what it does as an output, right? So that's our target, and this agent is much newer than the previous one, but it already works. And we apply it in client infrastructures, and it's already helping, especially new joiners. So you can imagine the new joiner comes in and he has nice documentation up to date because it was regenerated yesterday. So we don't care if there's no question if it's up to date, right? So that's already huge value. And that's our most ambitious stuff, which is not working yet, but it's in progress, and it may fail because it's so ambitious. Meaning, if you think about the DocumentAI output, it's a perfect input for prompt. So you can take the domain specification of what the code is doing. Of course, it's not prompt. You would need to extend it with some persona pattern, whatever, some decoration, and theoretically you could create it for example, our favorite COBOL to Java translation. Currently, every COBOL to Java translation creates Java code that looks exactly like COBOL, and this is not something that people like, right? So the idea here is to drop the source technology, go to the domain. It's very easy to say, very difficult to achieve. But the funny thing is that all those free large language models that are available and you can just download and run them for free, they speak COBOL. They understand it and they can read it, and they will know what it's doing. Yeah, so let me just end up with a motto. If you can imagine those people from the beginning of this presentation, they're not very happy working on this legacy stuff. So it looks like legacy is not good for people, especially wasn't good for me. But it looks like it may be a good match for machines. So I would just leave machines do it. So yeah, I think now is the Q&A. Możemy po polsku oczywiście.
Do we have any questions you want to ask? I come to you.
Okay, maybe in English. Two questions. First one is for the recent announcement about everything that will be generated by AI should have a watermark that it will be easily recognizable that it was generated by AI. But you told us that you are using on private. So what do you think that they will enforce this kind of like creating a watermarks on the engine level? That like, for example, your infrastructure will generate the test, everything, it will get any watermarks, or you think we will skip this?
So watermarks can be done in multiple ways, right? So if you just apply watermarks on top of large language model as a signal of statistics, let's say, it's quite easy to break it, right? You can just ask LLM to put pineapple word between each two words and then remove it, and it will drop the signal, right? So it's first of all, this is very easy to work around. In order to avoid the pineapple attack, for example, you would need to play with the insight of LLM, change the numbers, right? Parameters, values, right? So just not to trust this watermarking too much, right? From what I know, ChatGPT, they have the solution for watermarking implemented by Scott Aronson, but it's not on. They didn't turn it on. Right, so currently it's not working yet, because of those problems. Or if we don't speak about code, but we speak about English, you can just translate it to French, and from French to Polish, and you lose the whole signal. Yeah. None of the signals are that robust. Right? But in general, for those, we take the output from GenAI. Right, and of course, if we don't like it, we get another output from GenAI. So, but anyway, finally, whatever we accept will be some output from GenAI. So if the watermark is in it, for example, the statistical one, right, it will be in the code, in the pull request, right? So we will. So the way it works, it's the development team gets this pull request of 200 unit tests. They just take a look at usually at 5-10 tests, not more, because who reads 200, and they say it's okay, and the watermark would be there. So then it becomes intellectual property of the client, and if they modify it, they drop the watermark, right? Because each watermark has some robustness, meaning how much percentage of the output you can change to still find the signal, right? again, pineapple attack destroys them all, right?
Thank you. And the second one is more technical one, because you showed us the something that was generating the test, the gen module and the documentation module. Did you try this kind of case, like you got, for example, OpenAI or OpenAPI or Swagger, generate like update the code that this Swagger endpoints are like more descriptive that by default one, like.
But we would need to have a measure of this more descriptive, right? So,
like for example, the description of the parameters, description of what kind of stuff you can put in the fields, and.
So I mean, if you all this is very configurable, right?
Oh,
so
that's one question. How much you can configure?
The prompts are in separate files. So the way we do it, we deploy this stuff to the client infrastructure, and the prompts are in separate file. So if I find out that, for example, that's the worst, if all the code base is database centric, and basically every unit test, if it's done in separation, will try to come up with the same mock for database, and you will have the same 200 constructions of the same mock, right? So what you can do, you can create this mock yourself, the best way, just one, and say in prompt, extend this class, abstract unit test class. For example, yeah, you can do it this way. So every, I mean, in perfect world, there will be zero manual intervention. This is our target, right? But of course, the reality is more complex, and always we need to have this backdoor. And you just change one file, you add this prompt, please extend this class, rerun. And it's no longer mocked 200 times.
Okay, thank you. That's all from me.
Thank you. Any more question? Okay. Thank you, Adam.
Thank you.